So in this lesson, we're going to talk about generating displacement map, normal maps, and color maps using ZBrush. So as we said in the previous chapter, if you need to get your work out of ZBrush into a pipeline, like a VFX pipeline or a game pipeline, you're going to need to have two things. You're going to need to have a retopologized base mesh and UVs on that mesh. You're going to use those UVs to capture your polypaint detail as a texture map. That texture map can then be wrapped back onto the model in three-dimensional space in Maya or 3D Studio Max or any other 3D program. You'll also use those UVs to record your displacement or normal mapping. Now, displacement and normal mapping, those allow you to recreate the look of the high-resolution sculpture outside of ZBrush. The reason for that is you're going to be exporting level 1. If we go into frame mode here, you can see that this is on a ZRemesher mesh. It's organized with loops running around the major facial features and body features. And this is low res enough that it could be rigged and animated. Now, if you want to render this so it looks like level 5 in ZBrush, you'll need to extract your color map, of course. The color map we'll talk about extracting. And you'll need to capture all this high resolution detail, either as a normal map or as a displacement map. A displacement map is a grayscale map. Usually it's actually RGB, but it looks like values of gray. Everything going towards black pushes in, everything going out towards white pushes out. Displacement maps are typically used in film. The reason is that they have a lot of overhead at render time because the mesh is divided up to the same poly count at render time. So you end up with millions of polygons, and the displacement map will then push and pull the points so it matches what you see here. Normal mapping, on the other hand, is typically used in real time. Normal mapping gives you the look of the high-resolution surface by perturbing the surface normal, but it does not change the geometry itself. So while displacement mapping actually will increase the poly count at render time, normal mapping will not. That's why it's very important, if you're modeling for real time, that you are able to create a model that is within the target polygon count, but the silhouette still stays consistent. You don't have a big blocky silhouette because the silhouette will not be changed by normal mapping, whereas displacement mapping will change the silhouette. So let's begin by looking at how we will extract color. I've stepped down to level 1. Under the tool menu, I'll come down here to UV map, and you've seen this model already in the previous chapter on UV master. We have a single UDIM with 5 islands, the head, the antenna, and the ears. So it's a nice clean UV layout that was generated by UV master. Let's go ahead and unflatten that UV. Now what we want to do first is we want to capture our color map into a texture map. So you do that by going to geometry and stepping up to our highest subdivision level. Then we go to texture map. Under the texture map menu, we have an option for create. So if I go to UV map, I can set my resolution 4K, go to texture map, and I will create new from polypaint. And that will bake that polypaint into this texture map. And you can see that the width and height is 4K. We've got a nice texture map there. Now, if I want to export this map, if I click on this swatch, this is a texture subpalette. You see, all I can do here is import. I can't actually export from this. This texture subpalette is only associated with this Z tool. Whilst it looks similar to the master texture palette here, it is not the same. You see, you have many more options here. So what we need to do is click Clone Texture. That will clone it over here to the texture palette. And from here, I can actually export that texture map. So I'll just export this as color map. And you can export it as JPEG, PSD, PNG, bitmap, or TIFF. So we'll export it as a PSD. That's nice and portable. And there we go. Now, we're going to leave this texture map in the texture map channel here. And I'll go ahead and turn off the master texture channel. Now, while I have a texture map in here, if I go to Polypaint and turn Polypaint off, nothing appears to happen because we're actually seeing this texture map. But if I turn texture map off, then we see whatever my master color is selected here. So we have a color map in the texture swatch. If we go to displacement map and open this, we can generate a displacement. Now for displacement, you can either use adaptive or DP subpix. I find adaptive takes longer. So what I will do is I will set DP subpix to 1 or 2 and generate my map using this. These are basically just two different methods of generating the map. Adaptive will subdivide areas of the mesh with higher detail while it's generating the map, whereas DP subpix is kind of displacement subpixel accuracy. It's a global setting. These settings have actually, some versions of ZBrush, one has worked better than the others, but pretty consistently for the past few versions, DP subpix has been the one that I've been using. Adaptive, especially when we're extracting across multiple UDIMs using Multimap Exporter, which we'll talk about later in this video. This can take considerably longer. Smooth UV, I leave on. The only time I've ever had to turn off Smooth UV are when I'm working on an extremely low resolution base mesh and I'm trying to keep sharp angles. I was rendering a displaced coin once and I needed to turn off Smooth UV to get the displacement on the faces of the coin but maintain my sharp edges. We'll turn on Flip V because the texture space in ZBrush is actually different from that in Maya and Max and a lot of other 3D programs. So Flip V will flip the map vertically. We will turn on 3 channels, that is RGB. Now it will still look like a gray shaded map, and it's very likely, especially with more subtle details, that visually you won't be able to see the details in your map, but they're there. Displacement maps aren't meant to be read by the human eye, they're meant for computers to read. Now 32-bit. 32-bit will create a 32-bit floating point map. Now, this can be very valuable, and this is something that we use in production a lot in VFX. We'll use 32-bit floating point, we'll export as an EXR file, and we'll center our map on black. Now, that's something we're going to do later in this video. You can turn this on and extract a single map this way. The benefit of this is that if we don't use 32-bit, we get a 16-bit map, and so the texture or the displacement scale is going to be dependent upon the scale of the object and the alpha scale value. It can be a little tricky to set that up. If you turn on 32-bit displacement, then the object scale is baked into the map, meaning the highest point being pushed out and the lowest point being pushed in are both relative to the overall scale of the object. So as long as your object scale stays consistent, your alpha values in your displacement values will be consistent. So you won't have to go hunting and trying to figure out what those are, which is why we really do prefer those in production. And there's just more data there. So if you turn on 32-bit, you end up with a 32-bit map. Turn it off, you end up with a 16-bit map. Here, when you have 32-bit turned on, you do have a scale factor. I don't recommend changing that. I would leave that as it is. Now, we've got 2 options for creating the map. We can create displacement map, which will create the map and put it in the swatch here, or create an export map. So we can automatically export the map once it's done being created. So I'm just going to click Create Displacement Map. Now, we need to make sure we're at our lowest subdivision level for this. Now, it is possible to generate a displacement map from a higher subdivision level. Typically, we do that if we want to make a bump map. So, for example, this displacement map will displace the difference between this subdivision level and this level here, between 1 and 5. However, if I were to generate my displacement map from, say, level 3, you'll notice the only difference between 3 and 5 is very, very fine details. So that could be utilized as a bump map, which is just it's the same as a displacement map, it's just different ways of rendering it. A bump map typically carries very, very fine details, and it's used for rendering fine details. It doesn't change the geometry. Where a displacement map will carry primary, secondary forms, and tertiary details, and that will be rendered in a manner that actually changes the overall geometry. So we step down to level 1. We'll go back to our displacement map submenu and click Create Displacement Map. And you'll notice up here we get a status bar, and it says it's creating displacement map. It's casting those rays, as I said, it's calculating the difference between the low resolution and high resolution mesh, and it's recording those values as shades of gray depending on whether or not the object or the surface is being pushed in or pushed out. Once that completes generating, you'll see we now have that displacement map here in our map palette. You'll also see it displays on the surface as a bump map. And this is really handy just for checking to make sure everything's registered. It's a nice visual cue to see how things are lined up on your model. You can turn displacement on and off here. And again, if you want to export this, it's easiest to create an export, but you can clone the displacement map, which will place it here in the alpha palette. And then from there, you can manually export. Now, I should mention, remember, this alien only has one UV region. The UVs are only inside 0 to 1 for this character. When we're generating displacements and texture maps like this, we can only generate for the UVs that are in 1001 or the UV region 0 to 1. If we want to render UDIMs, we're going to have to use the Multimap Exporter plugin, which we will get to shortly. So we've generated a color map, we've generated a displacement map. Now let's go to normal map. So normal map is there. The normal map settings, we're typically going to use tangent space normals. Again, adaptive or smooth UV, or adaptive mode, we can turn that on. Smooth UV will turn on. Now the rest of these will leave as they are. These will work fine from Maya. Usually you won't change these unless you've been given specific instructions to do so in a pipeline, or if you know that for the engine that you're trying to render in, you need to have these changed. So it's very, very simple. All you have to do is click Create Normal Map, and again, make sure you're at the lowest subdivision level. I'll go to Displacement Map here, and let's turn Displacement off. We'll go back to Normal Map, and we'll click Create Normal Map. And once again, we'll have a progress bar at the top of the screen. It's processing adaptive rays, and it's generating this normal map. Now, normal map is an RGB map. It is a color map, and it's quite an interesting looking map if you've never seen one before. And what's happening is it's generating a normal direction for the surface, the high resolution surface, so lighting can be more effectively rendered on that surface. So in a manner of speaking, it's a trick of the light. You create the impression of an extremely high detailed surface on a low resolution model by perturbing the surface normals and changing the manner in which the light catches highlight and cast shadows as though it were a high resolution surface. So this should finish generating in just a moment here. And there we go. The map extraction is complete, and you can see it displaying on the model. Now, if I wanted to export this, I would clone normal map, and that places that in the texture palette over here from which we can export. And if we look at that map, you can see it's an RGB map, and we have different hues depending on the surface normal of the high resolution mesh, hence the term normal map. So now we have a normal map that's active in the normal map slot. We have a color map in the texture map slot, and we have a displacement map in the displacement map slot. Now, if I wanted to turn any of these off, I would just go to the slot here and click alpha off. If I click that again, I can pull it back in. So now I have generated those maps based on this character with just a single UDIM. Now, what if we wanted to generate maps with multiple UDIMs? Well, let's take a look at how to do that now. So here we have our Hellhound model. You may remember this from the previous chapter on UV mapping. If I step down to level 1 and then scroll down in the tool menu and go to UV map and morph UV, you can see that this particular Z tool has UVs laid out in multiple regions, or UDIMs. So when I unfold it, it looks like everything's stacked up on top of itself. If you have not watched the previous chapter and you don't understand what this means, make sure you watch the previous chapter on UV Master, because we will actually create the UVs for this particular character. If I go to Z plugin and tear off the Z plugin menu, I'm going to go back to UV Master just to touch again once more on the UV regions. So I'm going to click Work on Clone. That just makes a copy of my mesh with no texture map and no subdivision levels. And I will click Flatten. Now, typically on the previous model, the Alien, the UVs existed just in this square here. That's 0 to 1 or 1001, the first UDIM. UDIMs and UV regions are the same thing. UDIMs are just a method of naming and calling the UV regions. It was developed at Weta Digital several years ago, and it's becoming a standard in VFX. So when someone's talking about UDIMs, they're talking about UV regions. It's just a difference in naming convention and the way they're addressed. So you'll notice the UV islands for this particular character expand out in the positive direction from this first region. Remember, this is a Cartesian coordinate system. This is the y-axis, or V, and this is the x-axis, or U. So, or pardon me, no, that's U and that's V. So you don't want anything over here in the negative region. These stay over here in the positive region and go up. So the benefit of this is it allows us to generate maps for much, much more resolution. If I wanted to create displacement maps for this Hellhound, and I had to only rely on a single map, then I would be, I would be forced to create an 8K map or higher to get a whole bunch of detail for the entire character. But this way, we can split across multiple 4K maps, giving us plenty of resolution for this character. And you can end up with a lot of UDIMs in production, depending on the scale of the model and how hero that particular character is. You can end up with an awful lot of UDIMs, and that's fine. In VFX, it's not so much a concern how many UV cuts you have. If you're working in real-time, interactive, then there will be some concern with how many UV islands that you have, just in terms of efficiency and optimization for your particular engine. But as things move so quickly, even those sorts of concerns become less and less important. But it's good practice just to be aware of that. Now, we cannot generate maps across multiple UDIMs using the tools available under the tool menu. To do this, what we have to do is use Multimap Exporter. Now, I use Multimap Exporter to generate all of my maps out of ZBrush, even if I'm not using UDIMs, because it's so effective. It's a one-button solution, and it allows me to create settings for all of my different map types, extract them, and then walk away, go have a tea, come back, and they're finished. So I'm going to change my material back to basic material 2 because the UV Master automatically changes it to skin shaders so you can more effectively see the seaming. And I am going to just step my geometry up to the highest level so it's a little bit more pleasant to look at. Now I'll close UV Master and I will open Multimap Exporter. Now Multimap Exporter has all these boxes at the top. I highlight the boxes for the maps that I want to create. So I can create a displacement map. You can create vector displacement map. Now, vector displacement map is different from displacement mapping. Displacement mapping is based on grayscale values, shades of black and white, and it can only push in and out. Vector displacement uses RGB values. Now, this allows you to displace across a right angle or displace into spirals. You can see this in action in the chapter on vector displacement brushes. We actually use vector displacement in ZBrush to create brushes that allow you to create all sorts of complex compound forms and capture those details in a brush. It's really, really interesting. I've used this in production before. We used this on Pete's Dragon. I sculpted the irises and extracted displacement map or vector displacements for those. It's pipeline dependent though. These don't have sort of standardized settings. So if you are going to use vector displacement, you will have to actually work out the settings for your particular renderer, and that can change from version to version of Arnold or whatever your renderer may be. It may not be consistent between versions. You will do that by going to Preferences, Import Export, and Vector Displacement Map, and these are the settings that you will need to set up. under the tool menu, if I go to vector displacement map, here you see I have a diagnostic button. If you click diagnostic, it will generate a diagnostic file for you. And that is a file that you will take into whatever your rendering engine will be it Arnold or Katana, wherever you're rendering. And then you'll render this test file, and the test file will show you the settings that you need to set up in your vector displacement map export here. So it's a little beyond this video because it's different for every single renderer, while the other options here are relatively consistent. So if you turn on vector displacement and you have your settings set up correctly, it will export a vector displacement map for you. You can export a normal map, texture from PolyPaint, ambient occlusion, cavity, and you can elect to export your mesh. So these are all lit up, so all of these will be generated. Now, I don't want to click Create All Maps yet because I need to set the parameters for all of these. I can turn on subtools. If I turn on subtools, it will generate maps for all of my subtools. And here I have an option to merge the maps. Now, that is very, very interesting. Let's say, for example, I had taken this hellhound, and this hellhound is 11 million polygons right now. I have polygroups here. If I go into frame mode, I could go to subtool, and I could go to split, and I could split based on groups. That would split each polygroup into a separate Z tool. That would allow me then to divide up these parts even higher, and then I could get more detail on them. Now that would make this multiple subtools, and if I were to generate my displacement for multiple subtools and then turn on merge maps, when I generated all those displacements, it would merge them together into a single map. I'm not going to turn that on, but I just wanted you to be aware that that is there. And if you do use workflows like that, there's a bit more that you need to investigate in terms of buffer zones so you don't get seams along the edges. And there's a lot of good information out there on using that workflow. Most of the time, that's not going to be necessary. You will get plenty of detail out of UDIMs and 4K map per UDIM. That should be plenty. So we'll turn off subtools. Map size, we can set the size that we're going to extract. So I'm going to leave it at 2K just for the speed of generating the maps because we're demonstrating. However, I would probably set this to 4K in production. And of course, you can turn this slider all the way up to 8K if you want to. Map border, now that is the bleed along the texture edge. I would leave this at 4. I would not turn this down. I would leave this as it is. And of course, you can flip V. As we saw, that ZBrush has a different texture space than some other programs, so flipping vertically is important. When I was rendering in RenderMan at Weta, before they stopped using RenderMan, I didn't have to flip the maps in V because RenderMan shared the texture space with ZBrush. It was the same, so you didn't have to flip your maps. So that's not for all renderers, but it is there because for some you will have to flip. Many years ago, we had to flip manually, so it's nice to have a button there to do that for you. And you can recalculate smooth UVs to the highest subdivision level, and this can be good if you're getting artifacts along your seams. So if you find that your seams have artifacts, you can turn that on and try generating your maps again, and that oftentimes will fix those problems. Now we have export options. So if we open this, we have file names. If I click that, it brings up this menu here. So 16-bit format is going to be TIFF, 8-bit is going to be TIFF. Now, you can turn on overwrite existing files, and it will overwrite files in the same folder. And then we've got our map suffix. Now, you can leave these as they are. You might, if you are in a pipeline that has a specific naming convention. For example, I was at a studio who used dots instead of underscores between the map type and the UDIM number. So I would change this naming convention here just by clicking that and editing it. So instead of having -dm for displacement map, I would have dm dot. You can change all of these if you need to, but most of the time you won't need to actually change these. Now we've got UV tile ID format. Now remember, we have multiple UV tiles or UDIMs on this character. So if we use the UV tile format, that's UUVV. If we click that, we can change to UUVV capitalized. Change it again, we get UDIM. So I'm going to change this to UDIM and leave that as UDIM, and you'll see the numbering system that we end up with. So I can click OK here. Now we have a button to switch morph target. Now this is very interesting and very important in production. I'm going to step down. Well, no, I'm not going to step down yet. I'm going to leave frame mode, and I'm going to take my move brush. And let's say that you've been given this model by a modeler, and they say, okay, well, I need you to do sculpt some displacements on here and extract some maps. Okay, so this is the mesh you've been given. This mesh is currently in a pipeline being rigged and animated. It exists. It's already in the pipe. So you get your model, you divide it up and start sculpting. And in the process of sculpting, maybe you add some forms, some big forms here. So I'm going to take the move brush and pull that up. If I step down my subdivisions now, you'll notice that level 1 has changed. Now that is a drastic example, but all the sculpting you do in ZBrush, even just the act of adding a subdivision level, will perturb the vertices of level 1. It will average them out a little bit. And as you push things out, vertices will get moved out. As you push things in, vertices get moved in. So why is that an issue? The issue is because if we generate our displacement map based on the difference between, let me step back up to where this was, between this mesh and this mesh, those values are not very different because level 1 has perturbed. However, if we were going to be putting those maps on the model that's already in the pipeline, like I said, it's being rigged and animated, which is this one here, the maps that were generated between that other level 1 and level 5 are not going to be accurate because they're going to try and displace this shape based on values for a different level 1. Hopefully that makes sense. There's two ways around that. You can take your level 1 that's been perturbed, the one that's been moved, and that can be added as a corrective blend shape into the rig. Or the better solution, I think, is to store a morph target. So go to morph target, store morph target, and then divide up and start sculpting. So if I were to step up my subdivision levels now, and let's say I make big changes, and then step back down my subdivision levels, a morph target is a single copy of the mesh stored in memory. You can only have one morph target at a time. And if I click switch, you see it switches back to the original shape. Switch again, that's my perturbed version. So if I step down to level 1 and then switch back to the original unperturbed mesh, that guarantees the maps that I generate will match and displace this model to look like level 5. Now, if you forget to store a morph target, or if you're like me and you use morph targets for other things while you're sculpting and you overwrite your stored morph target, that's no problem. What you can do is at level 1, just go to import and then import your original base mesh with the UVs back into level 1. And then that will restore the vertex position. So as long as you don't step back up your subdivision levels after you do that, it will generate based on that level 1. So if you do happen to have a stored morph target and you want to generate from there, you can turn on switch MT. And that means that at the point that it's generating these maps, it will switch to the stored morph target. Coronavirus. Next, we have estimate time and reset. And these, I have never had occasion to use these, and I don't know that I would trust them, but I'm not basing that on anything in particular. It's just I don't find them to be useful, so I don't use them. But they do exactly what they say. They estimate the operating time for the current settings, and this resets all your settings to default. This could be useful, but generally I set my settings and then save them so I can distribute them amongst a team and everyone can be using the same settings. It's very handy if you get something working, especially when you're generating all these maps at one time to export your multi-map exporter settings and share them around a work group. Now, we have the settings for each individual map. Displacement map, now you will have seen these already. Adaptive or DP subpix, I set DP subpix to 2. leave adaptive off. The only time I would change to adaptive is if I were getting artifacts in my DP subpix generated map. Then I would set this back down and I would turn on adaptive. Smooth UV, 3 channels. Now remember, 32-bit. Remember what I was saying, 32-bit maps have the scale baked in. And for production, we turn on EXR. EXR is the most commonly used file format for textures in VFX pipeline. So we will turn on EXR. Scale you never want to change. I have never had occasion to change this slider. I can understand why you might, but I don't think it's advisable. There's 99.9% of the time you're not going to be changing that slider, nor will you change intensity. 16-bit scale, you can use the scale slider to set your 16-bit displacement scale. And if you click Get Scale, it will estimate the scale for your 16-bit map. So these can be useful, but generally, I think 32-bit maps are a lot easier, even if you're not using EXR, just because they have the scale baked in. And Maya, Arnold can render them. Most rendering programs can handle them. Next, we have vector displacement map. Now, again, these settings are, as they are, they're going to be fine here. Your main ones are going to be the preferences, import, export, vector displacement map settings. And again, those are generated on a case-by-case basis in your pipeline. So if you are interested, go ahead and export that diagnostic file and have a go at rendering it. It gives you instructions on how to do that and see what your settings might be in your renderer of choice. But we're not going to be generating those today. Normal map. By the way, I neglected to mention there is an extra slider here, subdivision level. Now, you remember how I said that you could generate a displacement map from level 1 or maybe from level 4 out of 6. And if you generate a displacement map, for example, we'll look at it again. If we go to level, let's say level 5, and then zoom in on our character, the difference between level 4 is better. The difference between level 4 and level 6, if you watch here, it's just fine details. Let's turn off the poly paint so you can see this more clearly. So we'll go back to geometry, level 4, and level 6. The only thing changing there is the very, very crisp details. So it is possible to generate a displacement map from level 4, and that displacement map would typically be loaded into the bump channel, because that is a bump map. All it's going to be carrying is the high frequency details. That's it. Now, sometimes you might find that you run into problems rendering your maps because maybe there is some overall displacement still in them, and you can tinker with your alpha offset settings to adjust that, or just your overall strength. I have done bump maps like this and used them in Mari. I've mixed them in Mari and gotten really nice results with that, and then painted extra bump detail on top. So it's really nice to know that you can do this. I'm going to go back to Subtool and turn my poly paint back on. Normal map, again, you can adjust the subdivision level from which you create that map. You can set tangent, adaptive, smooth UV, smooth normals. So these are going to be dependent on where you're actually going to be rendering the map. So what I would recommend for most applications is to come over here and set tangent, smooth UV, S normals. So it's tangent, smooth UV, S normals, and then leave everything else unticked, because those do work in Maya. Now, ambient occlusion map, this is handy. An ambient occlusion map generates a grayscale map where there is dark in the areas which are occluded. So it's a specific type of lighting, basically, where areas where you've got two things that are sitting close together. And let's turn off poly paint so we can see this more clearly. So here, for example, this area here is occluded by this raised surface next to it, and here, or this crevice down in here. It doesn't have to be a really, really tight crevice like that. Sometimes just larger areas like this are occluded, meaning the light is blocked slightly because two surfaces are meeting. So ambient occlusion maps are really handy. We can use them to punch up our lighting. We can use them, look dev artists can use them to adjust as masks to adjust where dirt will collect. Because if you think about it, an ambient occlusion map is going to generate data in areas where dirt and grime would typically collect. So they're really good for that. They're good for, if you invert them, you can use them to drive where areas are worn out as opposed to where paint wouldn't get worn down. For example, in the recessed areas, your paint might not get chipped away as much as they would in raised areas. So there's a lot of uses for them in LookDev as well as lighting. When we do our chapter on Photoshop rendering and concept painting, I use ambient occlusion passes a lot to punch up my shadows, and I use them as masks in Photoshop. So if we open up ambient occlusion, we can set our intensity, scan distance, aperture. We can make it 16-bit, and we can also change the colors. Typically, I don't change the color. I usually just change these settings here. Now, if you want to see what the map is going to look like, what you can do is you can change to a flat color material. Go to masking. Under masking, we have mask by AO, that's ambient occlusion. And here you can see occlusion intensity is set to 1. Our scan distance is set to 0.1. And our aperture is set to 0.90. Here we go. All right. So if I click mask ambient occlusion, this may take a fair bit of time to actually render. So I'm going to click mask ambient occlusion. It will generate the mask on my model rather than saving out a map. So ambient occlusion masks like this can be really handy when you're painting. So what I'll do is I'll click mask ambient occlusion. I'm going to do a quick save first, just in case. That's again the number 9. I save manually and I save iteratively. I always save with a 3-digit code. So this might be hellhound_001 or hellhound_002. Never save on top of the same file. And I save very, very often. But I also just make it a habit just to hit the number 9 because that saves a project file. It's everything on screen, my model in the same position, and it's saved in the quick save folder in the ZBrush install folder. Okay, so now let's go ahead and click mask ambient occlusion. And it's going to generate the ambient occlusion, and it does that by ray casting. And depending on how dense your model is and how many nooks and crannies it has, it might take a bit of time. So what I will do is I will stop the recording because all you're going to see is a progress bar going along the top of the screen. And we'll come back when this is finished generating and you can see what an ambient occlusion mask looks like. The ambient occlusion mask, using those settings, which are the same as these settings, will give you the exact same thing as a texture map, which that can then be used in any number of ways, like I said, in LookDev and rendering. And here you can see the completed ambient occlusion mask. I actually needed to change my settings. I raised the occlusion intensity to 8.75 and the scan distance to 0.67. So if you want something similar in your map, you would want to replicate this over here. So you would set your occlusion intensity to 8.75. Your scan distance, you would change. Here we've got 0.67 and it's 0.09, so set it to 0.67. This would be dependent on the object scale. And the aperture is still at 90. So we'll close out of ambient occlusion map. And then we have cavity map. Now, cavity maps are really handy also for LookDev, as well as for Photoshop compositing and painting. A cavity map will generate a mask where you've got dark down in all the recesses of your character. So I'm going to clear the ambient occlusion mask just by control-clicking and dragging on the background. It will close mask by ambient occlusion and open mask by cavity. Now, for mask by cavity to work, you want your cavity curve to look like this. So if we reset this, you may end up with something like this. What you do is you place a point about here in the middle, and then place another point and pull it straight down so it goes straight up and down. Turn your intensity all the way up. Blur can stay at 2, and then click mask by cavity. Now you want to generate this at a high subdivision level so you get shadows or get dark down in all the recesses. And again, this can be used in LookDev as a mask, or you can use it in compositing in Photoshop when you're painting your character up to create a dry brushing effect or mask out certain areas from certain effects. So I'll control click and drag on the background to clear that mask. And here I can click use curve for all subtools, and that will just use the cavity curve here. And you can set it to 16-bit, and you can change the colors if you like, but it's fine not to turn those on. Now, lastly, we have mesh export. So we have the ability to select the subdivision level, which will be exported, in this case, level 1. We want to export as quads. Now you can flip the faces of the mesh on export, which we don't need to do. And we have the ability to merge UVs. You absolutely want to turn that on. If you don't have that turned on, all your UVs will export as individual islands per face. Never had a use for that. Perhaps it's good the option's there, but it's always best to leave that turned on. Now, export polygroups with mesh. I turn groups off. Now, if I want to save these preferences that I've just gone through all this trouble to set up, I can click Load Save Preferences, and that'll save a preference file. And as I said earlier, you can then save that around a team so everyone's using the same settings to export their maps. So a couple things before we generate our maps. Make sure that Switch Morph Target is turned off in case you have turned that on. In this case, we're just going to be generating from level 1, so we don't actually need a morph target. So we're going to generate from level 1, morph target will be switch morph target will be turned off. And we also, I'm going to change back to our basic material 2. We're going to turn on the polypaint again because polypaint got turned off. If we don't have our polypaint turned on, then we're not actually going to see we're not going to generate the color map. We don't have to step up to level 5. We can, leave it at level 1. It doesn't matter because Multimap Exporter is going to automatically set the level at which the map is extracted, where we set that in the settings. So now we're ready to extract. I will just click Create All Maps, and we will get a folder pop-up here. Let me bring this over for you to see. I will select the Map Exports folder and click Save, and once I click Save, it will start to generate those maps. Now I'm going to stop the recording while these generate because it'll take a fair bit of time. We're set to 2K. We want to make sure that we're at I'm set to 2K. You might want to set your map resolution higher, 4K. 8K is a bit much, I think, for most applications, but definitely I wouldn't go below 2K. But even with that setting, with all these maps, it's going to take a little bit of time. So I will start to generate those. So we'll start to generate those, and then when it's finished, I will come back and we'll take a look at the result. Now our maps have completed extraction, and here we have the source folder where they have actually been generated. So we just drag this out, and you can see that they are named for the UDIM. So it begins with ambient occlusion, and if we just preview this and we can go through each tile, you can see the ambient occlusion maps. Next, if we go through, we've got the cavity map. And these will all register to the UVs, obviously, that we laid out. And the displacements. Now, once again, displacement maps may not appear as anything to the naked eye. Don't be misled if you just see a mostly gray image like this. This is a 32-bit EXR, so the maps are not intended for the human eye. They're intended for a machine to read. So there's an enormous amount of information in here, but it's so subtle, you're not necessarily going to be able to see it when you look at the maps. For example, this map appears to be empty. You might see some modulation in there. If you were to level it, you would see more, but definitely don't, because these are carefully crafted by the computer to have the correct displacement settings for the scale of the object. So I see a lot of times when people are new to extracting maps, they see their displacements and think that they don't have any data in them, but there's definitely information in the maps. It's just they are not intended for the human eye. And here we have our normal mapping. I've always quite liked the look of normal maps. I think they're very pretty. As we continue through, here we've got our OBJ file, which has been exported as well, and our color maps. Now these maps can be loaded up into any 3D program along with the model and applied and rendered. So you can use these in Blender, Maya, 3D Studio Max. The important thing is that you're able to capture all the detail of your model, all the color information, and the mesh itself, and then reproduce the look of your character outside of ZBrush in an animation pipeline. So hopefully you found this lesson helpful, and now you can go forward and create your own normal and displacement and color maps, and you can feel confident that anything you create in ZBrush, you can then render outside of ZBrush in the software of your choice. So thanks for watching, and I will see you in the next lesson.